Okay, these are the 7-4 notes using probability models. Okay, so example 1, we're going to develop a probability model. More on those here in a bit. So it says Mr. Campbell has a jar on his desk that contains 10 marbles. At the end of the class, each student draws a marble from the jar without looking, notes its color, and puts it back into the jar. If a student draws a red marble, the student will get a pass on that day's homework. Our question then is, how can the students determine the probability of drawing a red marble? So what we want to do is develop a model that basically tells us the probabilities of drawing each color marble. As we look in the jar, we have purple marbles, green marbles, and a red marble. So what a model tells us is basically the different probabilities of all these different outcomes. And what this model does, it tells us what the theoretical probability of drawing each one is. So what should my probability be when I put my hand in that jar? Okay, so let's define this a little bit. A probability model consists of a sample space and events within the sample space and their probabilities. So what is a sample space? A sample space is the set of all possible outcomes. So this is important. So in this case, our jar, an outcome would be drawing a purple one, a green one, or a red one. So what are the probabilities of each one of those things? Now what we need to remember is the sum of all these different probabilities, okay, of all the possible outcomes in the sample space must be equal to 1, right? There's a 100% chance of drawing a marble. So all of these different probabilities, all those percents must add up to be 1. So how can the students determine the probability of drawing the red marble? When a marble is drawn, there are 10 possible outcomes. So that's what our first thing is. There are 10 marbles in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 different outcomes. So we're going to use a probability model to display all of those outcomes and then find the individual probabilities of each outcome. So our sample space. Now our sample space is all of those outcomes. And how do we write the sample space? We use a big S like this, is equal to, and we're going to use these little brackets. Okay, and inside these brackets, we're going to list all of the different outcomes. So notice I have an R, and the R represents a red marble because there's one of those. We go here, and I have 3 G's. Why 3 G's? 1, 2, 3 green marbles. G represents a green marble. And then I have 6 P's. Why? Because there's 6 purple marbles. So my sample space is this. I have 10 outcomes, 1 red, 3 green, 6 purple. Okay. Now, you don't always have to put all these different outcomes. You could have an R, a G, and a P, but it is helpful sometimes when you just list all of them out inside these brackets. So that would be our sample space. This is part 1. Okay. We're just listing all the outcomes. Now, once you list all the outcomes, below that, you want to list the probabilities of all those outcomes. So we look at this. List the 3 possible events and their probability. So drawing a red marble. So we'd say probability of red is equal to 1 out of 10. 1 red marble out of 10 total. Drawing a green, just based on this, 1, 2, 3. 3 out of 10. Okay. Drawing a purple marble would be 6 out of 10. Now, when you add these up, what you need in your head to say is 1 plus 3 plus 6 should equal 10, and it does. Okay, you've got to account for all that. So this would be the same thing as 10% plus 30% plus 60%. Those all add up to be 100%. Right? And that's key here. All the probabilities must add up to be 100. So let's go back to our question. How can students determine the probability of drawing a red marble? Well, let's look at this. Boom, we just did it. It's 1 out of 10 or 10%. So we would answer it like this. The students in Mr. Campbell's class can use a probability model to determine that the probability of drawing the red marble is 1 out of 10. So basically, this is just a big thing just to say, what are my odds that I draw purple? What are my odds that I draw green? What are my odds that I draw red? And we're just kind of putting it in a box. We list all the outcomes, and then what the probability of each outcome is. Okay. So let's go to the next page. We're going to use a probability model to evaluate a situation. Let's see what we're doing here. So it says Mr. Stillman has a marble jar for the same purpose, but students do not know the number of marbles or their colors in this jar. Each of the 30 students draws one marble, notes its color, and then puts it back into the jar. So our question, based on the result shown in the table, what can the students conclude about the probability of drawing a red marble? So in this jar, we can't see the marbles. But what they're going to do is they're going to pick them, put what they put in this table, and then put them back. So before we were thinking about the theoretical probability, this one would be based on experimental probability because we can't see what's in the jar. It's based on trials and experiments. So we have red was drawn 4 times, blue was drawn 11 times, green was drawn 15 times. So we want to develop a probability based on experimental, and it looks like Mr. H made a little error here. The experimental probability. Okay, so number one, first thing, we list our sample space. What are all of our outcomes? Well, it should be pretty obvious what our outcomes are: red, blue, and green. So that's what we put. Put S is equal to red, blue, green. Boom. That's our sample space. And what we want to do using our table is that we want to create or list our probabilities based on our trials, our experiments. So drawing a red marble. Well, there were 4 red marbles, and how many times did we draw? 30 times. So we should have 4 over 30. Boom, we do. 4 over 30. Okay. Drawing a blue marble. We have 11, should have 11 over 30. We do, good. And then drawing a green, we should have 15 over 30. Let's check that. Boom, we do. Now, if you want to convert those into percents, you can do that also. But before we even do that, all of these should add up to 30. So 4 plus 11 plus 15 should give me 30. And you can check that at home, and it does. Now next, same thing with the percents. Say you converted all of these into percents. 4 divided by 30 gives me 13.3%. 11 divided by 30 gives me 36.6%. And then 15 is 50%. And if you were to add those up, you get about 99.9. But since these are repeating here, okay, we just go ahead and say it adds up to 100%. Okay, so that's important. All your probabilities must add up to 1 or 100%. Okay, now let's go back to our question. Based on the results shown in the table, so based on the experimental probability, what can students conclude about the probability of drawing a red marble? So what do we see for red? Boom, right here, 4 out of 30. So that's what we're going to say. Based on this experimental probability, Mr. Stillman's students can conclude that the probability of drawing a red marble is 13.3%. So all we've done here is use trials, experiments. We've listed a sample space. We've found the probabilities of drawing each one, and that's it. They have about a 13.3% chance of drawing that red marble. Okay, example 3 here. It says use probability models to make an estimate. So now we're going to use a model like this, and we're going to use it to project and make an estimate. I bet there's a proportion involved here at some point. Okay, so it says Mr. Stillman tells his students that the jar contains 100 marbles. So now they know there are 100 marbles. Based on the table of marble colors, after 60 draws, so students have chosen 60 marbles, about how many marbles of each color are in the jar. So what we want to know is how many marbles are in each jar. Okay, so develop a probability model based on experimental probability. Why? Because they're trials. We don't know how many specific colors are of marbles in the jar. So here, out of 60 tries, 7 were red, 20 were blue, 1 were orange, and 32 were green. So what's our sample space? Red, blue, orange, green. Those are the different outcomes. Boom. Red, blue, orange, green. Now we're going to list the 4 possible events and their experimental probabilities. So all we're going to do is just look at our chart. Each one of these should have a denominator of 60, and the numerator should just be what's in this table. So red, 7 out of 60, blue, 20 out of 60, orange, 1 out of 60, and green, 32 out of 60. Now, we want to figure out, what if there were 100 marbles in the jar? How would we find that? So we have to use proportional reasoning. We have to use a proportion like this. Okay, and each one of them looks like this. 7 out of 60. Okay, we put 100. And this number up here, that would be our unknown. Well, we'd want to cross multiply to get 11.6, or about 12 red marbles. We'd want to round that up. We can do the same thing for each one. And how do we get 11.6? 7 times 100 is equal to 60 times x. We divide to get 11.6. We do the same thing for each one of these. Now all we're doing is we're using this ratio that we've come up with here, boom, all of these, set it equal to something with 100 on the bottom and x on top, and we're cross multiplying and finding this number. Okay, so what we get 12, 33, 2, 53, boom, that answers our question right there. So our takeaway is probability models, right? A probability model can help you evaluate a chance process and its outcomes. It just kind of lists it all out for us. And we can make a probability model doing theoretical, what should happen, or experimental probability, what did happen. And remember, a probability model consists of a sample space, and the sample space is basically all of the outcomes and events listed with their probability. So one last little review item, we have a dice cube, got sides 1 through 6, so what's the sample space? You can get a 1, a 2, 3, 4, 5, and 6. And what are the chances? Well, it's all just 1 out of 6. So we've listed all of the different outcomes and their probabilities.